computing. MAC protocols. We are going to discuss about what is MAC protocols and wireless MAC issues, and we are going to have three categories, that is fixed assignment scheme, a random assignment scheme, and a reservation based schemes. So first we will understand what is mobile computing. So mobile computing is basically it is divided into two categories, that is mobility plus computing. So before going to the topic, we will discuss about what we are going to study in this mobile computing. That is mobility plus computing. So let's discuss what is mobility. That is capability to change locations while communicating to invoke computer services at remote computers. So first, in basics of networks, you may be studied about what is networking and how the data is transferred from one location to another location, how the data setup has been made, and topology, and what protocols you are going to use. And these are the basic things you are going to study in computer networks. Now we are going to have next category of networks, that is wireless networks. We are going to discuss about mobility computing, that is mobile computing. So in mobile computing, where we cannot stick with the one particular place while we are going to communicate. Okay, so at starting it may be of okay. So because in our networks we can divide our the entire transactions into two categories. That is, we can divide that into wired networks and we can divide it into wireless networks. In wired networks, when we have some restrictions, so we cannot able to transfer our data from long distance communications, and we have some restrictions is there. And that next level of extension is mobile computing. That is in category of wireless networks. We are going to have one category, that is mobility networks. So when we are going to have communications from one place to another place, can able to communicate our transactions. That is while we are transferring from one place to another place and some remote locations. When we want to retrieve some data, we can go with mobile computing. That is mobility computing. And computing is a process of using task technology to compute a given goal oriented task. So that is computing is we are going to have some specific task. So what task we have here we have taken is we have to complete our data transaction from one place to another place. So these are the five recent applications where we are going to use our mobile computing. So we will discuss one main topic alone. So MAC protocols, see we know that each and every layer has their own protocols, right? In MAC protocols, as we discussed about wired scenarios has their own protocols, and wireless scenarios has their own protocols, and Mac ad hoc networks also has their own protocols. As similar Mac protocols, that is our mobile computing technologies are that networks is also has their own protocols. So here we are going to discuss about three main protocols. Before that, we have some issues of protocols. Every protocols or every technology or every topology has their own issues. Like this, mobile computing has their own issues also. First is bandwidth efficiency, quality of service support, synchronization, hidden terminal problem, and exposed terminal problems. We'll see that later. First, we will discuss about the MAC protocols. So this MAC protocols is classified as three major classifications. One is fixed assignment scheme, second one is random assignment scheme, third one is reservation based schemes. So whenever we are discussing about mobile protocols, mobile computing, we are not going to stick with one place. So we are going to move from one place to another place while we are having data transaction. So at the time, how the protocols should act as, because every scenarios has their own protocols, right? So wired scenarios has their own protocols, wireless scenarios has their own protocols, ad hoc networks has their own protocols. Similarly, this is wired plus network. So first one is fixed assignment scheme. So fixed assignment scheme is every, it is also known as circuit switch schemes. So the scenarios or resources or channel is shared by nodes based on time, frequency, or code, right? So this entire transaction will based on some fixed assignment scheme. So whatever the transaction we are going to use, this entire transaction will based on a particular scenarios. So that is called fixed assignment scheme. So this wireless networks protocols will major classifications is three categories. So one is fixed assignment scheme, random assignment scheme, and reservation based schemes. So first we are going to discuss about fixed assignment scheme. So under that we have three categories: frequency division multiplexes, so time division multiplexes, and code division multiplexes. So first let us discuss about frequency division multiplexes. So the process of dividing the available bandwidth into multiple individual frequency bands. So assign the channels to the user. Only one user at a time, given time is assigned to a channel. So that is, so here we are going to divide our entire bandwidth into different individual frequency bands, and that is called channels. And each channel will be assigned to a particular user, right? So in that particular user, yeah, at a given time, yes, a user is allowed to use this data transaction. So here you will see with an example. This is the diagram for your FTMA, that is a frequency division multiplexes. Here this is your available bandwidth. The available bandwidth is divided into number of channels, and per channel a frequency has been assigned. A user is allowed to transmit a data and the particular channel allowed. So that is frequency based division. So what is the name given by this is, that is a frequency division multiplexes. So we are not going to stick with one particular user. We are going to have multiple users. So that is the meaning of multiple access point. So particular network we are going to receive the data from multiple access point. So we are not going to stick with one particular user, and for a particular user we cannot be able to assign a separate channel. So it is practically impossible. So only we are going to divide our entire protocols into three categories. That is fixed assignment scheme, random assignment scheme, and reservation based scheme. So first we are going to discuss about fixed, and fixed is entire channel is based on one particular scenarios, right? So that is fixed. So example is whenever we are going to travel our data in FM stations, or phone wired scenarios, or TV cable TVs. So these are fixed, that is based on frequency. So FM la when you are going to hear some songs, it is that particular FM is based on frequency. So if I want to hear songs in that particular FM, I have to tune that my radios into the particular frequency, so that then only I can able to hear some voice. So that data is tuned to that particular frequency alone. So that is called frequency division. And similarly, our cable televisions and set-top boxes, and when you are using some cable TVs, that is Airtel dish, or Reliance dish, or whatever the Tata Sky dish. So it is assigned to align to a particular frequency. And the particular frequency level and the data will be traveled. So if I want to hear some data, I'll travel our data now listen panano. My device has to assign to that particular frequency. So that is the concept of your FM stations, and whatever the devices we are going to use in cable TVs and set-top boxes. So like this, we also have so many examples for frequency division multiplexes. So in FTMA, the available bandwidth is divided into narrow, that is many narrow frequency bands called channels. So that channel is, we are going to assign for a frequency based. So each user has needed two link, that is forward link and reverse link. So forward link is your mobile to base station link, and reverse link is the signals what we are received from base station to the mobile users. So two channels are allocated to the particular user. So these two channels are unable to allocate to others users on one by. So these channels, if it is allocated to a particular user, the same channel will not be allocated to any other user at the same time. So here we are going to have two channels. One is a forward link and reverse link. The forward link is channel for communicating from mobile station to base station. So whatever the signals you are receiving from base station to mobile station. Second is reverse channel, that is downlink. the channel for communicating from base stations to mobile stations. So all uplink uses the bandwidth between 890.2 and 915 MHz, and download link is 932.2 960 MHz. So example, whatever we have discussed previously, that is our cable television systems and fiber optical communication systems and our FM stations all works based on this scenario, that is FDMA. So next one, time division multiplexes. So time TDMA allows the users to use multiple channels based on different time slots. All users or sources or uses the same channel, but at I will wait for time slots. The time slots allocated in the round robin manner. Unused time slots make the channel idle, so this leads to poor utilization of the channel. So whenever we are going to have this category, that is second category, that is time division, we are going to divide our entire channel in time based. Previous is frequency based. Now I'm going to divide my channel based on time. Okay, so example is previously we have 1 rupee coins and landline phones per second per call will allocate 60 seconds. For 60 seconds, if I want to speak, I'm having 1 rupee. That 1 rupee coin, this is the best example for TDMA. Whenever I put some coin in my coin box, I can able to speak for that particular call. That is, it is 60 seconds. After that, I cannot able to speak on the particular channel. If I want to continue, I have to make another time slot. That is, I have to book another 60 seconds time slot. So that is the big example. This is 1 rupee coin is the best example for your TDMA. So almost all MAC schemes for wired networks work according to this principle. Example, our Ethernet ATMs and token rings. So ATMs is also time-based signals. Whenever we are going to take amount or withdraw deposit, we have to wait for some period. So after that, within the time period with the transaction, if it is not completed, then automatically your time will be out. This timed out will be come. That is you have to wait for a particular seconds. So within that seconds, your transaction has to be complete. If it is not, you have to come from starting first itself. So that is TDMA. So this is the diagram. So I'm going to divide our entire channels into time slot based. So this is my entire channel. This is my bandwidth. I'm going to divide my entire channel into number of channels, which is based on time. So I am assigning this particular channel based on time to a particular one user. After that, the time is over. Next, he has to wait until the time has to allocate to the particular user. So next, code division multiplexes. See this code division multiplexes is CDMA. So CDMA technology, multiple users can use the same channel at a time. No scheduling is needed. Message or data is enclosed in one end and decoded in other end. So quite expensive procedure when compared to TDMA and FDMA. So allocate different codes for multiple users to access the same channel. Allows signals for multiple users to be multiplexed over the same physical channel. So multiple users will use the same frequency at the same time. Code is assigned to a particular user should have a good correlation. So this is the diagram for CDMA, that is different codes can use the same channel at a time. So real-time example is our mobile phones. So mobile phones, whenever we are using mobile phones from the second generation, so that is SIM card patterns. Whenever எப்போ வந்து SIM card வந்தது அப்படின்னா that is second generation. Whenever your mobile phones has been assigned to a particular code, and the code தான் we are supposed to transmit our data. So each user has their own mobile, and mobile phone has this specific code. That is our mobile number is specific code, and that specific code my data is supposed to transmit from one location to another location. நம்ம SIM card use பண்றோம்ல, so அந்த SIM card the best example for CDMA. So whenever I want to transmit some data, I am able to transmit only on the particular code. அந்த கோட்ல தான் நான் data transmit பண்ண முடியும். So entire channel is divided into code based access. So that is CDMA. And we'll have SDMAs also, space division multiplexes. Second, a random assignment scheme. So in random assignment scheme, each channel has owned a particular. So a user has a random chance to own the channel. Whenever he is assigned to a particular channel, he has to transmit his data. So here we have three types of schemes, that is pure Alaha, sorted Alaha, and CSMA, that is CSMA bar CD and CSMA bar CA. That is collision detection and collision avoidance. So pure Alaha, this is don't wait method. Whenever you have data, you are allowed to transmit our data. So here we have four stations. And the four stations, whenever I have some data, I am able to transmit my data. Whenever more than one packet is overlapping, we'll have collision detections. So second category is slotted alloha. To what are the disadvantages comes in alloha, it is overcome in slotted alloha, and slotted alloha by fixed time slots, and that particular time slot I'm supposed to transmit my data. So here our network has four stations. So station 1 transmits some data in slot 2, and station 2, whenever his next slots come, he has to transmit data in the particular slot only. So station 2 has no data to transmit in slot 1. He has some data in slot 2, and slot 3 he has no data, and slot 4 he has some data. And similarly station 3, slot 1 no data, slot 2 he has his data, slot 3 no data, slot 4 no data, slot 5 no data, and slot 6 yes some data to transmit. So whenever a station has data transmit, whenever the time is allocated to the particular station, it can able to transmit data. Whenever we have more time slots for a particular station, we'll have collision. Two or more time slots, two or more stations say share the same time slot, then we'll have collisions. To avoid that, we are going to have some other techniques, that is CSMA bar CA, that is carrier sense multiplexes. Here we are going to have two techniques, that is CSMA bar CD and CSMA bar CA. So we will discuss that. One is one persistent, non-persistent, and P-persistent. So one persistent is I'm supposed to transmit only one data at a time. So I'm going to continuously sense my channel. If I'm continuously sense, if the channel is busy, I'm not able to transmit my data. Whenever the channel is idle, I'm going to send my data. That is, I'm supposed to allow only one data. That is one persistent. So carrier sense multiplexes is more than how I'm going to sense my carrier and how I am going to transmit my data. So first one is one persistent. I'm going to sense my channel continuously. If I'm having my data, then I will able to transmit my data. One persistent. Second one is non-persistent. So I'm not going to continuously my sense my data. I will sense one time. If it is busy, I will wait for some times. After few seconds, I will sense. If it is busy, I will wait for some time. And whenever I sense, if it is free, I'm able to transmit my data. I'm not going to sense continuously. I'm going to have some time period. Be persistent. I'm going to transmit my data at a probability of P. I'm not going to sense continuously. I will have some, whenever the channel is idle, I'm going to send my data with a probability of P. That is not uh, five data or six data with the probability